All right, welcome back for page 2 of the Unit 9B Circles Part 2 test review. In example 3, it says to find the value of x in the circle below. I can see that I have two chords that are intersecting in the circle, so the products of the pieces that the chords are divided into are equal to each other. Remember, when we say product, that means multiply. So if I take this chord, it's got x and 15, so if I do x times 15, that's going to be equal, then I do the other side, 10 times 24. So x times 15, that is 15x, and 10 times 24 is 240. Then I'm going to divide both sides by 15. And 1x equals 240 divided by 15 is 16. And these are units. 16 units. All right, let's look at number 4. What is the center of a circle if its diameter has endpoints at 7, 2, negative 6, negative 5? So let's see where those are. 7, 2, 7, 2, and negative 6, negative 5. Negative 6, negative 5. So this is my diameter, and I want to know where is the center. Where is exactly halfway in between, right? So my circle looks something like this. And I want to know where along this diameter is my center, okay? So I'm basically just looking for the midpoint between these two. If I look at my formula chart to find midpoint, I'm just going to average my x's and average my y's, which means I would take my two x's, my 7 and my negative 6, and I would add them together and divide by 2. And then I would take my y's, my 2 and my negative 5, and I would add them together and divide them by 2. So 7 plus a negative 6 is 1, divided by 2 is 1/2. And 2 plus a negative 5 is a negative 3, divided by 2. So I end up with 1/2 and negative 3/2. 1/2 would be right here, and then negative 3/2 would be right here. So here is my center, exactly halfway between my two endpoints. 1/2, negative 3/2, which could also be written either of those as decimals, 0.5, and negative 1.5. 0.5 and negative 1.5 is my center. You can write it either one of these two ways. My center for number 4. All right, let's look at number 5. Find the measure of angle 1. Remember, your angles in circles can either be in the circle, on the circle, or outside the circle. Angle 1 is in the circle. So the formula we're going to use is that the angle is equal to 1/2 the sum of the intercepted arcs. So this angle that we're looking at, angle 1, is going to be 1/2 the sum of the intercepted arcs. So as I come out of that angle, I can see one of the intercepted arcs is 56. And then if I come out of its vertical angle, the other intercepted arc is 50. So the measure of angle 1 equals 1/2 of 56 plus 50, which is 106. So the measure of angle 1 equals 53 degrees. All right, let's look at number 6. What is the perimeter of the quadrilateral that is circumscribed around the circle? So that means each one of these sides of the quadrilateral is tangent to the circle at the point where it touches that circle, meaning that the segments that leave at each corner are equal. So if this is 8, this is 8. If this is 6, this side is 6. If this is 7, this is 7, And if this short little piece here is 1 inch, this little piece here is also 1 inch. So now my perimeter, let's see how long my sides are. This one's going to be 8 and 6, which is 14. This one is going to be 7 and 6, which is 13. This side is 1 and 7, so it's 8. And this side is 1 and 8, which is 9. So then my perimeter, when I add the 4 sides together, 14 plus 13 plus 8 plus 9. My perimeter is, let me grab my calculator and make it a little more dim because sometimes that affects things, makes it harder to see. Alright, so 14 plus 13 plus 8 plus 9 is 44. And do I have units? Yes, I do. They are inches. 44 inches for number 6. Okay, so that concludes page 2 of your Unit 9B review. Come on back for the next video and see page 3. Thank you so much for watching.